Hello, everyone. This is Robbie from the Fair Podcast. This is episode 3, and today's going to be a little different. We have a guest host today, Dr. Mel. I'll let him do a little bit of introduction and a little bit and everything that he's part of. But today it's going to be pretty casual, pretty laid back. We're not going to go into anything too formal. We're just going to talk about just AI that we're interested in the medical world and some of the papers we've seen, some stuff that has been happening. In a broader context. So this will be for the more research paper oriented, for the people that are more interested in the application or some of the stuff that's happening in real world instead of kind of broad ideas we've kind of covered in the past. So hopefully y'all are interested in that. And Dr. Mel, if you want to go ahead and give a quick spiel, advertise some things that you have going on, because I know you've got multiple things that you're part of, and I'm excited to hear about them.
Thanks, Robbie. Yeah, so it's Dr. Mel Spiceman, and I'm the president of a professional society called the American College of Artificial Intelligence and Medicine. And I launched that organization about a year ago, last August. Uh, and really, what it boils down to is this, that at every academic center, there are a core group of individuals like you guys that are really trying to do both research and education of your colleagues around how to use artificial intelligence, in our case, to help patients or help the biomedical community. So, what I learned is that, in every subspecialty society, there might be a committee that handles this. At every university, there's a center or a core group that does it. But, before we turned on the podcast, Robbie and I were talking about the notion that all of these are siloed, that everybody's in their own little pod or bubble. And so there wasn't, what I noticed in all of my work is no professional home, no place where we can all gather together in a scholarly way. So, for example, there's an American College of Cardiology. Literally every cardiologist in the nation is a member of that organization. They have their national meeting, they present their research, they have their journal, and it's a community. And if you are active in that organization, you become a fellow of the American College of Cardiology. And this is worldwide. This is so well acknowledged. It's a professional home for every cardiologist, literally in the planet, not just in the US. Well, I'm internal medicine, and I've been a member of, it's called American College of Physicians. It's for internal medicine doctors. That organization has over 120,000 physicians that are members. I've been a member for 30 years. I'm a fellow of that organization. So similarly, since I saw that was lacking in true AI, the kind that we're all doing at our core institutions, I created a professional home, and that's what it's about. And I've been connecting literally with every center or institute in at every medical school in the US, over 200. Everyone has a center, an institute, or a where they pull in people in every department that are like-minded, like the three of us are. So that's what I've been up to. Prior to starting what I'm doing now, I was a professor at University of Illinois College of Medicine. I went to medical school there. More recently, I was a professor in the Division of Academic Internal Medicine. And as we all have recognized, AI has emerged as like a transformative tool that we can use in powerful ways. And so there's a lot of enthusiasm. I was just at the oncology meeting here in Chicago a few days ago. It's ASCO. There's like 50,000 people that come to McCormick Place. The president of the organization, keynote speech, how to use AI in oncology. They had the president of Google there, how to use AI in oncology. About a quarter of the talks there, how to use AI in oncology. The same thing happened at our national meeting in internal medicine. The same thing is happening in every subspecialty of medicine. That within either the last year or so, the conference has become consumed with the theme of AI and how to use it within every area of medicine. So that's kind of who I am and what I'm up to and why I'm talking with you guys. So I reached out to Robbie a few months ago to connect with what we're doing because I identified him and Fahim as leaders in this area. And he has been really kind enough to have me talk with you guys on the podcast today. So that's kind of my brief intro. I don't want to go on and on, so I'll turn it back to you guys.
Yeah, we appreciate it. It's not so much kindness on my end, it's kindness on your end for coming on and talking to a couple of PhD students. We appreciate you coming. Yeah, I should have mentioned that we have the other PhD student here, Fahim. Uh, my bad for skipping over you, but I just kind of
Whatsoever.
assumed at this point people know that you're here.
Yeah.
We're 3 episodes in, so if anyone's missed you,
Now,
it's on
just to
them.
spin on that, I want to share with the audience is um, I have a podcast, but actually the best podcast there is on AI and medicine, and I'm just very transparent and honest. And it because is New England Journal of Medicine AI podcast. And the reason I mentioned that, it really ties into what Robbie just said, which the people that host that are PhDs that trained at Harvard, two PhD students that stayed on as faculty. And their podcast is the best. They actually launched it a year before their journal was launched, the New England Journal of Medicine AI. So, in a similar way, I really love this idea that both Robbie and Fahim, two PhD students, are launching a podcast because I really feel that you guys are like the perfect people to host a podcast and talk about what our organization is passionate about, which is the evidence-based medicine, the science, the papers around AI and medicine. I love that Robbie wants to discuss some of the papers. I actually spent the last 72 hours looking through in preparation for our national conference, identifying the most important evidence-based papers in Nature, all of the Nature journals, in uh, the Lancet Digital Health, um, in all the JAMA journals. So I've like picked out the most important, most transformative, most impactful papers. So we're all aligned on like that's what we're about. We're about the science, the evidence, not the hype, and there's tons of hype and there's tons of like just broad strokes. But this core group that is we're pulling together, we're the science behind all of this. So it's like just so joyful just to be on the talk with you guys today.
Yeah, and like you mentioned earlier, the with bringing in trying to connect all of these siloed groups in AI, that is exactly why we ended up creating FAIR in Wake Forest because we had all these people that are in these different labs in different buildings around the city, around the state that were doing really cool work, but we had little to no interaction with each other. There wasn't a lot of instances where students would interact and talk about the work they're doing. So that's why I ended up deciding to start the student org. I immediately tried to pull in Fahim as soon as I could. Got him involved. We've been going for I think about 2 years now. So I very intimately agree with the fact that we need to pull in as many of the medical AI people as possible before we get left behind by the rest of the industries and start talking about these papers and what we're doing and try to help each other out on a lot of this.
I had a,
Were you about to say something, Fahim?
yeah, I had a quick question about Dr. Mel's experience. Like, for the last 72 hours, since you were doing all that kind of research, like, I came with a bunch of questions beforehand, and one I was really wanting to ask, and I would like to see your perspective because you're in a unique place where you're a physician kind of approaching this problem, whereas we're kind of the people who code and do all the basic stuff up. I wanted to get an idea if you feel like there's a certain disease state or a certain kind of clinical scenario that gets more attention compared to other models, and if you feel like maybe there are disease states that do not get attention but should get attention.
Great question, Fahim. There's two ways to think about it. One way to think about it is what area of medicine has the FDA approved AI medical devices? And there are over 1,000, and that field is in radiology. So there is a disproportionate amount of AI for patient care in radiology. And then in That's literally 75%. And then there's 10% in cardiology. So now we're up to 85%. So that means all the other medical fields, everything, which is a lot, right? Is representing just 15% of what is commercially available for use. So that's, I'm not talking about the publications or the literature that you guys and I are really about, but that's what's available for patient care. So there really is a disproportionate amount in radiology. And that's due to industry. Industry has paid for and patented and marketed only really imaging based um, solutions, primarily computer vision, not large language models. And they have tried this year to deploy that in all the major medical centers in radiology department and not a whole lot else. The only other area where there's been deployment is not really specific to a area of medicine, but it's in this what call ambient listening. So you guys may or may not know that in virtually every medical center now in the nation, ambient listening is being deployed. And so it doesn't really relate to a field of medicine. It's just in an office setting, regardless of it's a heart office or a lung office or a kidney office or a primary care, regardless of the type of office, um, the AI tool that's fully deployed throughout the country is this speaker that's listening to the conversation and then converting it into an electronic medical record. And that same tool is being used to reply when when you see a doctor now, it doesn't matter who you are, what age you are, what type of doctor, you're given something called a patient portal access to your electronic medical record. Well, patients then send a message to their doctor securely through that portal. So, the other way that AI has been very actively deployed right now is to answer patients' questions to their doctor on the portal, and then AI generates a draft. The doctor then reads it, tweaks it, and then clicks send. So those are like the ways that AI is being used in the real world today. But if we back up and we look at the medical literature, it's a little different. So I prepare a talk for doctors at 5 different hospitals here in Chicago once a month on a different specialty within medicine. And what I can tell you is in every single specialty of medicine currently, on average, there's at least 1,000 or more new papers per year, or since 2020, about 4 to 5,000 per specialty, which is enormous. Like if you plot it on a curve, it's a nonlinear exponential growth curve from 2000 until 2005, and it's ridiculous the volume, the content of publications. And the quality is really there. I mean, we're talking really good work. So basically, if someone's doing biomedical research in 2025, the likelihood is that they will use AI as a tool, regardless of what the project is, so that most publications now have some component of AI built into some aspect of the research that's being done. And I'm sure you guys would concur. I know you're like guys are well on top of the literature. Uh, and actually, most of the good work that's being published or has been published, the one that we would say is like the best of the best, is published by PhDs or MD PhDs. Physicians like myself are now on board, but we're like late entry into things, in my view. I mean, the three of us are not late entry, but mostly it's been the PhD world that's been on it. So you guys are really doing the right thing, getting a PhD, and because you're going to be real difference makers. But I think the key is this is where the magic happens, is if the two of you collaborate with a physician or like myself or any of the hundreds of members in our organization, if you do a collab, whether it's a PhD working with an MD, now you create magic because then you have your skill set plus my clinical experience knowing what the problems are. So where it falls apart is when a PhD solves a problem but doesn't really consult with the MD. So it's like it works, your solution works, but is it like relevant in the real world? And so I know you guys are well attuned to that. So it's really important for us not to be siloed and to kind of work together on projects. So our organization is all about connecting MDs with PhDs in computer science, biomedical engineering, bioinformatics. That's really what our organization is designed to do and create magic, you know.
It's so ironic you mentioned lots of these points because I grouped my questions to three themes. One was what kind of high impact disease states for AI research. Another was communication between clinicians and AI engineers. And the third one was translatability. And you kind of tackled all three of those themes with your answer. I had like a bunch of follow-up questions, but I didn't want to steal from Robbie. Do you have anything before I kind of go into some of these?
Uh, the main question I have is in regards to literature. So if you want to continue down this for a little bit, we can, once you ask your question, then we can hop into some of the papers that we've seen recently.
I'll limit to two of them, and then I'll stop talking because I came with too many. So one thing that you mentioned at the very beginning of your explanation, which was really ironic, was talking about the computer vision kind of application in the radiology kind of world. Um, personally, from my research, I'm in a unique situation where I work with both AI applications for biomedical signals, and I also was getting very deep into the computer vision kind of world for ultrasound images. So it's not necessarily radiology, but it's a close-ish enough.
Yeah.
And one of the funny things that I noticed was that when it came to the radiology literature, I was overwhelmed with the wealth of different models and different strategies and things I had to compete with to make an effective model. But for the biomedical signals, I was like dealing with very, I don't want to say like and use negative terms, but very non-sophisticated models. And I realized that part of that is because of the fact there's so much interest in the computer vision kind of application of AI models. And that's it's very interesting that at first I thought I was crazy. I was like, maybe I'm just looking at this wrong, but it's interesting that others are seeing this trend too. That was the first thing. So I wanted to ask based off of that, um, do you think that there will be a trend in the future from industry to kind of move towards these other modalities, or do you think that because it's kind of people are really developing this computer vision kind of world for the radiology, is it kind of going to follow that trajectory for a while?
No, I really think it's the future of where everything is going. Like if we look at today moving forward, is honestly it's how to deploy the use of large language models. And really, if you understand, I don't want to dwell on the history too much because people don't. I love the history of all of this, and you guys might or not. But I find that listeners don't want to know the history. But I'll just say this, that some PhD students in Toronto that um, were working with, this past year's Nobel Prize in physics in 2011, a guy named Alex developed computer vision AlexNet to read images, and it wasn't for medical images initially, it was just to read images. And that quickly in 2011, you know, after the NeurIPS type meeting, became like the way that images in medicine were going to be read using AI. And that's why we can read a chest x-ray or a CAT scan or an MRI. And but the next frontier, which is what you're asking about, which is not that method, but how do we use large language models to do like multimodal things in a, when I say things, combining the labs and the x-ray and the history and the electronic medical record, like combining, because how does a doctor think? Or how does a human think, let's just say, about a problem? We're not unimodal. We're like, okay, here's a patient sitting in front of me. You tell me your story. I process that. Then I examine you. I process that. Then I look at the blood work that I sent on you and I process that. Then I look at the images that I took on you and I process that. And then I combined all those elements. So really everyone who's at the cutting edge that's doing the real work that the three of us are interested in are doing now the next phase of this, which is a multimodal approach the way that a real physician would try to figure out your diagnosis and what your treatment plans should be. And so to do that, you essentially have to have a large language model. You can't do that just with computer vision. Computer vision is only going to read the image aspect, but we need all those other elements, which are basically you need to combine, let's say, computer vision with a large language model to really replicate the way a physician would go about solving a patient's
Right.
presenting symptom. So, but up until today, that's why it's just, well, let's have an AI that could read the X-ray. But that doesn't really look at the more global picture of, well, how do you actually take care of the patient who's in front of you in so I know you guys get it. I'm just hoping the audience follows my line of reasoning, but that's where we're going right now. So hopefully you guys are going there with me.
Yeah. It's very, very interesting you mentioned this multimodal aspect because this actually is also my second question too, which is interesting you kind of went towards that. The research I was working on beside that I was hoping to turn to postdoc, not sure what we'll be with that yet, was developing a multimodal model using both the ultrasound images I mentioned before and the physician reports that were generated in the clinical setting. So I was making basically basic natural language processing models to extract key information from the physician reports to include them as kind of biased terms when I was analyzing the ultrasound image and extracting key features from that. And one of the things that I found really guided me through that process. I got like probably a third of the way through this in my free time, was constant communication with a clinician. Because me, my background is mechanical engineering. I have zero clinical skills. I will never ever claim to take the job of a clinician. But I've also noticed that if I was left by my own devices, I would have taken a completely different turn. And in your first response, you mentioned this too, that engineer by themselves may not really solve a problem that's even a problem. So then my question really is, how do you think is the best way to structure that collaboration between the clinicians, what they want, and what the AI engineer can actually do and create to really solve these real life problems?
That's what I asked myself. Uh, that same question, 2 years ago when you started doing the same work that I'm doing, and I answered that question by saying we have to have a professional society, like every other specialty in medicine has, and that's where the collaboration is going to happen. So, with our organization, we have representation in virtually every nation in the world, and I have college students, I have medical students, I have resident doctors, I have professors from almost every medical school in the nation and many worldwide. And so I'm creating this collaborative community where we all have this dialogue like we're having today. And hopefully we gather either live or virtually in Chicago each year at McCormick Place. And we're taking abstracts now, poster submissions. We have categories for all of the research for whether you're a college student, a medical student, a resident doctor, a PhD, and a faculty physician. So, my hope is through your podcast and our podcast, through our journal, through our organization that people can become a fellow in, through our national meeting, that just like the cardiologists do, just like the oncologists do, just like the radiologists do, that we create this global community where we collab together. And I basically try to be the one worldwide that connects the dots, meaning you tell me what problem you're solving, and I have someone in the country, or I'll just like someone walked Robbie over to your desk and created magic. That's what I would do. You just let me know what you're up to, and I'll connect you with the right person. They might be in Switzerland, they might be in New Zealand, they might be in Norway. I'm only giving you those examples because I really do have membership and faculty that we work with in those countries. I'm not just throwing out random places. And these are some of the best people in the world, and they want to collaborate with you guys, and they want to work on projects together. There's a lot of energy, a lot of enthusiasm, a lot of interest in collaborating and finding like-minded people. And so I think in any field of science, the way you make these connections is through a professional society, really. So that's how I answered the question to myself, and that's why I
Mm.
launched the organization. And so now I'm just trying to get the word out. So part of why I'm here is just to get the word out to not just your listeners, but to anyone who's interested in AI and medicine at the level that this three of us are discussing. If this is on point with what you're doing or what you want to do, then think about coming to our meeting in Chicago or think about becoming a member of our organization. And we're not for profit. And if you're a student like you guys are still, or a resident doctor or a fellow, we don't charge you anything for being a member or for coming to our conference. So we're really educationally driven, and we're not about like profiting off of AI like most of industry. We're trying to do the things that we're talking about here today, which is connecting, creating a community, having a place where we can meet nationally every year. There's tons of journals. That's not an issue, but I think the national meeting and the organization, that's where I think connections happen. And we have actually 25 virtual lab groups that I oversee, one for every specialty of medicine that meets once a month on Zoom to allow these kind of collaborations that you're asking about to take place.
Yeah, and we'll definitely link that in the YouTube video. So anyone that is listening that is interested, wants to attend in person, virtually, whatever, that'll be down in the description. On the note of where things are going in AI, talking about the use of large language models and stuff like that, we already see companies like InSilico. You mentioned an Alex earlier. The CEO of InSilico was Alex, and they're using large language models to do drug discovery. I think they kind of specifically do aging research, but they just had a drug go to clinical trials that is performing incredibly, and it was all just AI discovery, and they've trained these models and all of this data, and they're doing really well. And then we are also seeing DeepMind and DeepSeek in China that's starting to get into the medical world and trying to bridge that gap to train their model on medical research to see what it's capable of. So we're seeing a lot of these large language models start to tip their toes in, or some people starting to implement them. So I think you hit the nail on the head right there. One of the things that I'm really interested in right now that's kind of uh, caught me by surprise, I guess, because I've always heard this. I've heard about agent-based systems, but I've never really looked into them, and I've started looking into them recently, and it's surprising I haven't heard more about them because you're essentially just building an employee. You're building a someone or something. It's architecture that you give text input to the same way you would a large language model, but it interprets that input, and depending on what you say, it goes to a certain like block in it essentially. So if you're asking it if this patient has a tumor or something, then it'll go through this kind of system that you set up, and it'll go to the image analysis, and it'll go through and look at that image, and it'll know to do that instead of looking maybe at their transcriptomic information or maybe their blood work or anything like that. So there are these already kind of the groundwork to build these multimodal systems that you don't have to pick from. You just tell it what you want it to do, and that it could access that, and it could do a lot of this work on behalf of clinicians or whoever needs to use it, really. That has been really interesting to me. I'm really excited to see how that's used in clinical settings. I'm not sure if either of you have delved into the world of agent based systems as I have, but it's really blown my mind.
I read very, very basic stuff about it, to be honest, and I did not actually realize it was a growing field. I think if we actually had a speaker come to Wake who basically designed something along those lines to really just try to simulate those actions and interactions of different autonomous entities. But it's very interesting that I didn't realize it was actually growing besides that kind of small setting.
Yeah, there's a the website that I think I see recommended the most, and it's usually for just kind of helping you manage day-to-day tasks.
Mm.
So you could have something that takes voice input that you design as an app, and you just open the app and you say, "Hey, what's the weather for today?" And it will know to go to uh, your, let's say you have it account connected to your Google account. It'll look for your location, and then it'll go to the weather app, and it'll look for the weather in that area, and then it'll use a large language model to summarize that and then give you a quick 2 sentences about what the weather is like and if it's okay to go jogging or whatever. So it's really developing, and I think the website that I see a lot of people reference is N8N, and it's really fascinating to see what people are doing with it. It's kind of like playing with Legos. It's just building this system to do kind of specifically what you need it to do. Um, and it's been really fascinating, kind of in that same kind of automation realm. One of the papers that I've been really excited about, I guess, that might scare some people to hear. I'll go ahead and I'll drop it in the chat here in case you guys want to look at it or look at it later. It's the title of it is the AI Scientist version 2 workshop level automated scientific discovery via agenic tree search. So this is a research paper that was written by a group that developed an AI algorithm that did everything from beginning to end of a research topic and even wrote the paper. So it's just an entire research paper where it came up with its own hypothesis and everything, and it's been approved for publication, I believe. So this is a paper about that and about the model and everything. So it's the automation of some of these things. Like it's kind of scary to think about, like, well, we're automating science at a certain level, but at the same time, like this is really interesting. If you have a task that, let's say, you want to do some kind of meta analysis of a topic, then it could be something where it does that for you. You can publish that, and you can also use that as the basis for a research project or a grant or something that you're working on. And like that's been really fascinating to me. I've been They have a GitHub link to the code and everything that I've been meaning to dive into, but uh, that's the one paper that I've been kind of blown away by. I think it was published last month or a couple months ago. So with that said, I was going to ask you two if there's any papers that you've seen in the past 2 or 3 months or so that have just kind of blown you away with how far this is going.
Well, let's Fahim go first. I'm curious what papers you like in AI.
Yeah. So I was actually reading an older paper because it's more relevant to my research. What they did essentially is like, oh, I'll give some background actually first. My research, like for my PhD, focuses on hemorrhagic shock. We basically simulate hemorrhagic shock in animal model, and from there we collect high frequency data. And one of the tasks I did was to really try to classify the level of shock in a patient, not by knowing how much blood they lost, but by actually taking a small sliver of time in the actual patient's body itself, or their self, I guess, not itself, and to really try to predict how much blood the patient lost. Now, this, as you can probably imagine, it would be very highly unethical to do this in a human being. So that's why we use like animal models instead for this kind of work. Now, what one group did that was very fascinating is that they actually used some very old technique that was used by the army research to really simulate hemorrhage in a human being without actually taking a single drop of blood out. And what they did is they performed this really advanced feature engineering process. Feature engineering for the listeners, essentially when you have like a signal and you try to really extract key features from that signal to train like an AI model, mostly machine learning models will you use this kind of technique. And what I found was interesting here is that they basically solved the problem. Well, not solve the problem, but gave me steps to solve my own problem while doing a completely different kind of methodology. So what I did is originally I was using a deep learning model to really accomplish this task. And then I was like, you know what? What if I replicate the kind of work that they're doing in their human model, which was for a completely different kind of function altogether, and extract the same features, do all this kind of stuff that they're doing, but for a different modality. I went through the process of doing this, and I also kind of added some of my own kind of twists and turns. Like I use something called genetic engineering for a different time. I'm very sorry, not genetic engineering, genetic algorithm for a different discussion. And I was able to create a machine learning model that worked just as effectively as a deep learning model, just by replicating their technique. Even though they actually did not get much success in their paper, I was able to beat a deep learning model with just a machine learning model, which I always am really happy to see something like that happening. And again, it doesn't sound as like cool and fancy as some of this as some of the, like the multimodal models, but in the kind of signal processing world, especially of biomedical applications, there's not much literature out there. So for me to be able to take something that's very far away from my research, reapply it, and then beat what the normal kind of process would have been was for me very impressive and kind of opened my eyes to actually one of the questions I asked earlier, like what about these underserved kind of fields in the AI world? What if we could reapply these models that are in the bigger, more fancy world like radiology to something that's less, less researched? So yeah, that's kind of just one of the papers I read recently that really struck me as really fascinating.
I do want to follow up on Fahim's point, which is really so well made, and it really reflects your depth of understanding of the literature. So well said. When I prepare these talks that I told you about, I go to hospitals when you're done with medical school, you have to do 3 years of what's called residency in a specialty, whether it's my field, internal medicine or surgery or radiology or whatever it may be. You do 3 to 5 years of training at a hospital in a specialty outside of your medical degree. And so, aside from teaching medical students, I have always taught resident doctors as well. And so I go to 5 different hospitals and lecture at noon, they take a break from seeing patients and they have lunch in a lecture hall where the different doctors come in and do PowerPoint talks. So I do one each month on AI, a different field. So I prepare a different specialty topic every month by reviewing the literature the way you guys would. And what I will share with you, especially in all these other areas that are less well represented, there's incredible studies that are truly impactful. And what's interesting is that they are AI, but they're not like the AI that the current people are using. They're all machine learning models, and these studies are fabulous, and they're really work. And like for example in oncology, they could detect cancer like a year sooner and save a life in an amazing way. And they are using machine learning. And so if you like did a graph of the different methods, it's more like random forest or XGBoost machine learning, that these are the real impactful studies, not LLMs. If you look at some of there's tons of newer literature on LLMs, but I love what Fahim said. Like if you get at what really works and can make a difference in caring for a patient, it's actually a machine learning model that has an AUC in the high 90s and it's just we, meaning the three of us and our like-minded colleagues, need to get the word out. So that's why I go to 5 different hospitals and teach every doctor I can about what Fahim just mentioned, which are these machine learning models that you can then deploy and use to help diagnose and treat patients. And you know, many people who are superficial just know the AI of the large language models and ChatGPT or similar thing, but they don't realize, like you guys do, that it's actually these other machine learning models where there's thousands and thousands of studies, like literally 4 or 5 thousand studies in each field of medicine showing specifically, that an XGBoost model can actually identify cancer, a year sooner and save a life. I'm only giving that example, but I can give an example in every specialty of medicine. The papers that I like the most, honestly, right now are in cardiology because what we can do is this. Virtually everyone that enters the medical system ends up just as a baseline, aside from getting their blood drawn, they get an EKG, even if they don't need it. I'm not saying that's right or wrong, it's just done. Like I went to see my own personal physician who's listed as one of the best in Chicago by Chicago Magazine, who I personally trained, and he did the most thorough physical exam imaginable that anyone could possibly do. He's like, and it's not just me. I've sent many of my colleagues there. They say the same thing. He's perfect, most thorough exam. But he did an EKG, and I'm thinking, well, I don't need an EKG. I'm not having any symptoms. But he did one. But why this is impactful in our conversation is if you train a model on that EKG and say 100,000 or 500,000 echoes and labs. Now you all you need is an EKG and it can predict correctly what my ejection fraction would be, what my labs would show. It's real. So, and virtually everyone has an EKG. So if we went back in someone's electronic medical record and just used computer vision to look at their EKG, we can then find and predict and identify all kinds of things that are unimaginable. And the same thing with the eye exam. So, in a similar way, and this is, you asked, well, is there something that blows your mind? I'm going to tell you what blows my mind. And I have my lab group in neurology working on this. You can look in someone's eye, take a photograph of the back of their eye, of the retina, show that photograph to computer vision, and it can correctly identify Parkinson's disease, Alzheimer's disease, cardiovascular disease, diabetes, years before the patient will ever have signs or symptoms that they would go to the doctor for. And why that blows my mind is if I could find it 6 years, 10 years before it's clinically apparent and affecting the patient, then I might be able to impact on that. I might be able to use CRISPR technology and intervene before they get a disease. So that's kind of what's blowing my mind, and where my interests lie is in those things, in looking at an EKG and seeing things that don't have to do with the heart, because that's data is virtually available on literally every human being almost that enters the healthcare system. And the same thing with the eye, like the eye as a portal into everything that's wrong with you medically that it hasn't even become clinically relevant yet. And so these are ways that you could like intervene in a preventive way before, because once someone gets a disease and it's obvious that there's something bad going on, it's usually too late to turn it around. Whereas if we could find it 5 years, 10 years before it has impacted their life, and we can do something about it early, that's our opportunity to be real difference makers. So that's kind of what I see as like being the future. Eventually we'll get there. Like if I had a crystal ball and I was like gonna say, hey, 10 years from now, where is AI gonna really like be a game changer? It's in what I just told you. It's preventive medicine.
Yeah, that's a
It's
lot
very,
of what my research is looking at is preventative measures in aging. Um, do you have something you want to say, Fahim? After that, we'll probably start wrapping up.
yeah, I was just gonna say it's very interesting that you mentioned this because one of my committee members, and probably Rob, you can talk about this too, Dr. Ogus Ogbilgich, I think it's pronounced Ogbilgich. I always messed up his pronunciation, but he just recently started working on a study, and I think they actually published, if I'm not mistaken, where they used EKG to be able to try to predict in advance either Alzheimer's or Parkinson's. I forget which one. I think it was Alzheimer's. Do you remember, Robbie?
Not the top of my head. I've seen him talk about this, but it's been
Yeah.
months.
Yeah, I believe it was Alzheimer's. And at first, when I saw the title, I was like, what does an EKG have to do with Alzheimer's? But when you realize that there are so many secondary markers that you can actually, if you feature engineer well, or if you use like really highly perceptive models, you can really try to catch these secondary maladies from very and like normal data sets that you would not normally like consider to have a connection to that system. And I use the word system because sometimes us as engineers, we think about these things as almost like different parts to like a machine. Like, oh, the eye is only focused on the eye, the heart's only focused on the heart. But reality, the body is a system. And as I started to realize this more, I realized that there are other signs that you can really try to farm out from like something as simple as an EKG that I think we are sitting on treasure troves of data that we just need to like understand better and learn how to really wield to be able to capture some of these kinds of more translatable elements into the research.
Well, when I do my podcast, we at the beginning, like other podcasts, have a quote from the whole talk that's like 30 or 40 minutes. If I had to pick a quote right now, I would pick Fahim's last three sentences where he says, we're sitting on this treasure trove of data that's going to transform medicine. I really love that. I think that should be the take home from today's talk. Well, if you like what you heard today, you could be like Robbie and Fahim and become a member of our not-for-profit professional society, where you can engage with our lab groups, or you can arrange to have me do virtual or live talk at your medical center. If you want to come to a national meeting, submit an abstract or a poster, or just come and listen to talks at the level of the discussion that the three of us had today. September 19th and 20th is a Friday, Saturday in Chicago. And if you can't seem to make it live and you want to watch it from your home, then just sign up to the virtual one and you could participate from home. And hopefully you'll engage with Robbie and Fahim's organization at Wake Forest and Virginia Tech, and hopefully you'll engage with our organization and be part of a more of a global community to use AI for good in ways that will help make the world a better place and help improve medical care and advance science and research. So those are my final thoughts, but I'll turn it back to you guys.
Yeah, thanks for coming on. We uh we really appreciate it. This has been you're our first guest, and this has been the best guest episode we'll probably ever have. Not to throw shade at anyone in the future, but I've really enjoyed this talk. Uh yeah, so if anyone is listening, obviously join the organization. If you want to, you can join the Center of AI Research at Wake Forest. If you're a grad student at Wake Forest, you obviously can join the Future of AI Research. That's our grad student org. We also have it open to students, anyone really that wants to join, they can. You can get updates. We have a little Discord server. It's not super active, but occasionally some of us will post papers and stuff in there. So feel free to reach out. And next episode, we'll be back to our regular kind of uh, structure, I guess, where we'll go into I believe we'll jump ahead a little bit and maybe do some natural language processing, some LLM stuff next episode, and go back and forth between deep learning and machine learning and some of these. But hopefully we can get that done in a couple of weeks or so and stay on track. But uh, thank you, Dr. Mel, for coming and joining and having a wonderful conversation. And if I can't make it to the conference, I will definitely be there virtually. So I will at least be able to interact with you in some digital capacity. Fahim, do you have any last words you want to say?
No, I really appreciate this discussion. It's always nice to be able to kind of talk about these things openly and not have to, always question my sanity. Like, am I saying something wrong? It's, I don't want to consider it echo chamber. It's more of like people are all thinking the same way. And now we can get those people into a room or virtual room in this case and be able to talk about it and really share our thoughts and feelings about how this field is going to grow. So I really enjoyed having you here, Dr. Mello. Definitely would like to keep in contact with you a lot more and pick your brain about more of my other 30 questions on my list.
Absolutely. You guys are welcome to call anytime. It's a pleasure. This was a great conversation. I enjoyed it as much as you guys did.
All right. Thanks again, and we will see you all next time.